again because there'll be new people joining us. So Michael Grimlich is an instructor and freelance consultant for data science, machine learning, and data strategy. Before that, he worked as a data scientist at Alexander Thumb, consulting for multinational corporations across Europe. He is passionate about implementing data science and machine learning projects end-to-end, from the conception until deployment of operational data products that generate real value. The only thing he loves more than getting his hands dirty with data is sharing his expertise and experience, which he has done in many trainings for various international companies and universities. He holds a master's degree in international economics from the Graduate Institute of Geneva. So with that, I will pass you the presentation. I'm pretty sure it'll be very engaging. So I encourage everyone to listen intently and pose your questions during this session. And these, as Michael has mentioned, they will be addressed at the end. So Michael, over to you.
Perfect, great. Thank you, Edison. I think you've said it also. I'll get right into recapping what we did in the last two webinars and what we're going to do today and in the coming ones. So recall that in the first webinar, we talked mostly about the big picture and the why, right? We said that there's a thing going on which is called digital transformation, and it's somehow affecting companies of all sectors and of all sizes. And while this digital transformation was previously driven by simply adopting digitalization technologies, increasingly it's being driven by big data and everything that you do with big data. And so last week, on the 5th of August, what we started looking into is the field of data analytics, which means, you know, basically looking at your data to gain some valuable insights from it. And we've started looking at simple data analytics use cases, so examples of what some companies are doing. And today what we're going to be looking at is looking at more involved data analytics use cases that are implemented with machine learning and AI. Also recall that last week we briefly talked about the cloud, and the cloud is nothing else than renting or using somebody else's computer resources. And these resources could be simply storage of data, but it could also be entire softwares that you use of cloud service providers, for instance, your Google Mail account or web hosting services. Good. So what we're going to be looking at today is artificial intelligence, machine learning, and basically what this means for you. You will see that today is probably the webinar of this 5-part series, which is maybe most interesting, but at the same time relevant in terms of implementability, only partially, and we'll see why. Because to implement artificial intelligence and machine learning, you need certain conditions and requirements, and we'll get into that later. But I think it's still very important that we cover this, because there is ways for everyone, I think, to make use of these systems, and there will be increasingly ways for you to make use of these systems, and because they're getting smarter and easier to use. So it's a good way. So it's a good thing to know about these concepts anyways, to see how they work. And starting next time, we really talk about you and your companies, and we'll get into how you can identify where you can use data analytics, simple use cases like we had last week, but also maybe more advanced use cases like we're going to talk about today. And what I want everyone to learn today is A, what AI and machine learning is, B, I want everyone to get a sense of what is currently possible with it, to de-hype the whole topic in a bit and gain some objectification of what is true and possible and what is simply hype and fiction. And I want everyone to learn how you can potentially use machine learning in your system. Good. So there was a quote by a professor called Dan Ariely a few years ago, which was very trendy, and the quote was, "Big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it. And so everyone claims they're doing it." And in this world in the sector where I'm working, data, big data, artificial intelligence, machine learning, I think the concept of big data, the buzzword, has basically been superseded by AI. So if you go to any sort of tech conference today, everyone will be talking about AI, and people say that their business is AI driven and their product AI driven. So it's really, I think, at the peak of the hype cycle, and it's good to get some clarity on what it is. So let's talk about this. One of the reasons there is so much confusion about AI is because it essentially refers to two things. The one thing is that it's a field of study, so it's an academic discipline which you can study at many universities. And this discipline is concerned with figuring out what is AI and how to create it and what makes machines different from humans. So it's actually quite interdisciplinary field. And secondly, what AI refers to is computer systems or machines that display some sort of intelligent human-like behavior and capabilities that allow them to perform tasks which will usually require human intelligence. Okay, so what is AI? For the rest of this presentation, I want everyone to simply think of AI as a computer or an algorithm which is able to perform a certain task or take a certain decision based on an input. So it's a bit like a human in a certain regard. A second reason why artificial intelligence, why there's been so much confusion around it, is that if you define AI as a system which is intelligent, then this raises the question, okay, but what is intelligent? And because intelligence, or what we deem as intelligent, is an evolving concept, this is not a straightforward question to answer. So, you know, in the 1960s, we suddenly had calculators which were able to perform very simple algebraic mathematical tasks. And everyone was probably like, wow, this is amazing. Then you jump to the 1980s and suddenly you have computer games and computer bots, which are computers who play computer games. And everyone says, wow, this is amazing. And calculators have become normal. In 2000, the new interesting wow thing is machine translation, and Super Mario is super normal. And then you jump 20 years ahead. In 2020, now we have chatbots and all sorts of other fancy AI systems, and everyone thinks that's amazing. And for us, machine translation system is just, it's the new normal. Like, there's nothing special about it. And in 20 years from now on, I don't know what we're going to have, but I'm sure that people will look back and say the stuff that people had when the Corona crisis happened in terms of AI was a joke. And so AI is inherently an evolutionary concept, and this is why it's also jokingly sometimes referred to as almost implemented. And I will give you many examples today to see where we're at and what is already implemented and what is still sort of fiction. So to make sense of AI systems, because we have this confusion, there's two dimensions or two distinct categories of AI that I would like everyone to recognize or to see. The one dimension we can distinguish is in terms of software-based AI and hardware-based AI. Because I think when many people hear the concept or the term AI, what they think of automatically is some sort of robot like the Terminator or R2-D2 from Star Wars or any sorts of other things. And yes, this is also AI, but if you talk about hardware-based AI, then you are basically talking about the intersection of artificial intelligence as it's actually classically, as we think about it, or as I think about it, mixed with the discipline of robotics. So you have a robot which has some sort of software in it which is intelligent, and this robot is able to act on what the software is telling it to do. In contrast to that, you also have merely software-based AI systems. So this is really only, think of algorithms, and it's a computer who is able to give you a certain output or calculate something for you, but it's not connected to a robot or to an actuator or to some sort of machine which will then physically do something for you. A second distinction, which is important to make and which I think gives a lot of clarity, is that we have to distinguish when we talk about AI systems between what are called weak or narrow AI systems and strong and general AI systems. Just 1 second, I hear a bit of noise from someone. And just a reminder to please everyone mute themselves so that we don't have any interference. So maybe just check if you're muted or not. Or maybe Edison, you can mute people, that'd be great, thank you. Good, so types of AI systems, we have to distinguish on a continuous scale between weak and strong. And weak or narrow AI systems are systems with intelligence for only one specific or narrow task. And actually these sorts of AI systems we've been having for a very long time already. So one example of this would be your spam filter algorithms in your email services. So everyone has these, I'm sure. And it's basically an algorithm in your email provider, which checks every email and classifies it as spam, yes or no. And then you might have a bit more sophisticated AI systems, which are a bit more intelligent, let's say already, such as chatbots that are able to perform a more complicated task or a wider range of tasks. And at the other extreme, what everyone thinks of, I guess, is when we're talking about AI is strong or general artificial intelligence, which are systems with intelligence across the entire spectrum of human reasoning and activities. So this is what everyone thinks of humanoid androids like Sony from the movie iRobot or something like that. So we are still very, very far from creating strong or general AI. So we're still far and we're still many decades away from a scenario where the robots are becoming like humans and they're taking over the world. However, we are currently somewhere on the left side of the scale and we're quite rapidly advancing to the right side. So spam filter algorithms have existed for a long time. Now we have chatbots, which become increasingly sophisticated. And a next big milestone will probably be autonomously driving vehicles. And you can think of many, many other milestones that are happening in every sector, whether it's agriculture, tourism, or textile and apparel. Good. So the main takeaway is when we talk about AI systems, we have to classify them in terms of how strong they are. Are they only able to perform one certain task, or are they able to perform many tasks? And depending on that, we classify them as weak or very weak or not so weak or strong. Good. The dream to create systems that are intelligent has been around for a very long time. And we usually say that AI as a discipline has been created in 1956 by a group of very smart researchers at American universities. Since then, there have been many, many approaches tried to create such AI systems. For example, one of those approaches is called rule-based learning. And the idea was simply that you create a system which follows certain rules to arrive at a decision. Example, many of the early machine translation systems in the 1960s and 70s were based on such a rule-based system. So the rules of the system would be take a word, look that word up in a dictionary, get the translation of that word, and assemble all of the words in a sentence to get a new sentence. Now these approaches typically, basically almost all of them were pretty terrible. And one of those early machine translating systems was of the United States Army. And they wanted to create a translation system to create Russian artificial intelligence, Russian academic papers to see how they're doing with their race to the moon technology. And one of those systems they tried out and they had the English sentence, the flesh is willing, but the mind is weak. Or is it the other way around? The mind is willing, but the flesh is weak. What they did is they translated it into Russian and from Russian back to English with the same system. And the resulting sentence was something like, the vodka is excellent, but the flesh is rotten. So these systems were typically terrible. However, in the last 10, 15 years, something amazing happened, which is that we had a new approach coming up, which has actually been around for many years. But this approach started to produce incredible results in terms of artificial intelligence. And this approach is called machine learning. And the idea of machine learning is that you teach a machine to learn a certain task by simply providing it with data. And we'll talk about this more in a second. But basically, machine learning has become so important as the main approach to create AI systems that today people say AI is essentially nothing else than machine learning. And so really when people talk about AI, or when someone talks about AI, actually what they have to be talking about is machine learning. It's simply that AI has somehow managed to become the buzzword that has caught on more, but actually AI is nothing else today than machine learning, because this approach has created many impressive results. Within machine learning, within this discipline, also to have these terms covered, there are different models you can use. And one of those models are called neural networks. And the idea of these models is that they try to emulate the structure of the human brain to create AI systems. And if these neural networks are very complex and very large, we call them deep neural networks. And once a neural network is deep, or we train such a neural network, this is called deep learning. Just for everyone out there who might have heard of the term deep learning, it's just basically one type of machine learning you can do, and machine learning is just one approach to create AI systems. So AI is computer systems that are intelligent, and basically today when you talk about AI, you have to talk about machine learning. So today's session is actually mostly dedicated to what machine learning is, how it works, and what you need to create it. So the quote here is, machine learning is really the evolution of statistics, and more specifically predictive modeling. As we will see, the reason why machine learning has become the most important approach in creating AI systems, and the reason why machine learning is yielding so impressive results, is because the main determinant of the performance of machine learning models is the amount and quality of data. And now please recap what we learned in the first webinar is that we have currently an exponential growth path of data, and what we're seeing currently is basically an explosion of data. Now, the more data we have, the better the machine learning models will be. The better the machine learning models will be, the more sophisticated our AI systems will be. This is basically the reason why everyone is talking about this kind of stuff today. At the end of the day, everything breaks down to the fact that we simply have more data available to us. So what is machine learning and how does it fit into this puzzle? Machine learning is basically a field of study which is concerned with algorithms and statistical models and computer systems, with the goal to give computers the ability to learn a task without being explicitly programmed to do so. So instead of having to write very long programs, computer programs that perform a certain task, essentially in a nutshell, with machine learning, we have the ability to just feed all of the data we have into a machine learning algorithm, and this algorithm will learn by itself without us having to give it many more instructions. Recap also from what we talked about last week, that there's different types of data analytics to combine these buzzwords. And to answer the question, how does machine learning and AI come together with data science and data analytics and predict advanced analytics? The answer is that in many cases, what we want AI systems for us to do is to make a certain prediction, or to maybe even give a certain prescription. And so recall from last week that there's different types of data analytics use cases: descriptive, diagnostic, predictive, and prescriptive. And all of the use cases that we want to implement, which fall under the category predictive analytics or prescriptive analytics, they have to necessarily be tackled with machine learning methods. Or let's put it this way, once you have such a case, you will employ machine learning to create such advanced analytics use cases or to implement such advanced analytics use cases. Good. Why is machine learning so powerful? I've just already mentioned it, but I want to give everyone an example so that you get a grasp of why this is so powerful. Let's say we have an advanced analytics use case, which is to classify bank loan applicants into trustworthy or not. So basically, as soon as someone, imagine you're a bank and you have applicants who apply for mini loans or for certain loans. And you will have to make a prediction whether or not this applicant is trustworthy and whether or not you should give him a loan or not. In the old world, let's say we have a rule-based approach. The way we would have to create such a system is we would have to write a number of so-called if-then statements. And the way this works is that we write a program and the computer will, by means of this program, arrive at a certain decision. And the way it would do that is it would look at, okay, if the income is more than $1,000 and if the gender is female and if something else and if something else and if something else and if something else, then classify the applicant as good. However, if the income is more than 500 but less than 1,000, and maybe if the gender is male and if the age is below 30 and if the location is something and if the number of children is something, then classify this customer as not trustworthy. So to write such a program, I think everyone understands that you would need a lot of domain expertise and you would need to write a very long program, and it's not very straightforward to do. Now we could create the same system with machine learning, and basically the only thing we would have to do with the machine is to give it historic data. So we would tell the machine, look at data of previous applicants. We'd have to specify what it should pay attention to. So let's say we wanted to pay attention to the income, gender, and job status of an applicant. And then we would basically click a button and the machine learning algorithm would then find relevant patterns and would find the patterns that it needs to classify an applicant into trustworthy or not. So how does this work? And what ingredients do you need for machine learning to create such a system like I've just shown? On a very abstract and high level, what you need to create such a machine learning system is basically 3 ingredients. The first one is you need a certain task to be learned, right? In the previous example that we just looked at, the task to be learned was classify into trustworthy yes or no. In this example, what I have is the task to be learned here would be if a website visitor comes to our website and we are an online shop for toy cars, make a prediction whether or not this website visitor will click on a product link, yes or no. So this is the task. Now, the second ingredient you need is you need a historic data set. Historic data means you need a data set of, let's say, 1,000 website visitors, which contains the information how they behaved in the past. So concretely, you would need a data set which contains, let's say, information on the age and the location and maybe the gender of the website visitor, along with the information on whether they clicked on a certain product link that you displayed yes or no. Then the third ingredient is a machine learning model. And basically what you would do is you would chuck in all of this historic data into the machine learning model. And the machine learning model would then by itself, if you give it the task to classify into yes, person will click on link or no, the machine learning model would find patterns by means of which it can do the task. For example, there might be a pattern in the data which says that people from Germany, like me, are much more likely to click on Mercedes or BMW cars, whereas people from Japan are much more likely to click on Toyota cars. There might be a pattern in the data, I don't know, but there might be a pattern that female website visitors are more likely to click on yellow cars than on black cars. There might be a pattern that people of a certain age bracket are more likely to click on certain products than on others. Now, you do not even have to worry about these patterns because your machine learning model will automatically identify them. And once it has done so, you basically have an AI system. So once the machine learning model has looked at the data and learned from it, we call this process model training. Once the model has been trained, you can use it as an AI system. So you could simply feed new data into it. So you have, let's say, a new website visitor. You could chuck their data into the AI system, and the AI system will look, okay, this is a female customer from Japan. So I will, the likelihood that this customer or visitor is clicking on a yellow bus from Toyota is positive. And so, yes, this person will click on the link. And then you could obviously try to take the product link on which the customer will most likely click to increase your conversion. So in a nutshell, what you do is you simply take a machine learning model, tell it what to do, give it the data, and the machine learning model will then figure out all of the patterns that are in the data by itself. And with these patterns, you can use the model to create new predictions about the future. This is basically how it works in a nutshell on an abstract level. This is something I would also like to discuss really briefly so that you at least have heard of it. There are different types of machine learning, and these basically refer to different ways that a machine can learn. And in general, we distinguish between what is called supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is what we looked at today. It's called supervised because basically we tell a machine to perform a certain task for us, like we did now. We tell it, hey, classify product into yes, will be clicked on yes or no. And in this process, we haven't gone into this process deeper now, but in this process, we basically give it feedback in an automated way and say, if the model made a right prediction, we tell it, yes, this prediction is right. And if it made a wrong prediction, we tell it, no, this prediction is wrong. And so basically you can think of us being a teacher for this model. And this is why it's called supervised learning. Within supervised learning, within this type of learning, there are two different categories. One is called regression problems and the other one is called classification problems. And they differ in terms of what the task that you want the model to perform looks like. And concretely, in terms of statistics speech, we speak of what the target variable looks like. So one might be a continuous case. So let's say you want to predict what the stock price is. So in this case, your target variable is continuous. It's simply a number. And the examples we've looked at so far is categorical variables. So it's simply a yes or no, or maybe green or blue. And so in both cases, the way the machine learns is the same. It's just that the target variable that we're trying to predict, or put differently, the task takes different shapes. The second way that a machine can learn is what is called unsupervised learning. In unsupervised learning, the thing is that we don't have a target variable. So let's assume that you have, we have textile producers here, right? So let's assume you produce t-shirts. And if we had data for each t-shirt that you produce, if it's correct or if it's okay, and if it satisfies all quality checks, then we could create a machine learning model which predicts based on some data. I don't know what's important in the t-shirt processing industry. Based on certain variables, we could write an algorithm which is able to predict whether a t-shirt will be produced as an okay t-shirt or whether there will be an error. Now, let's say we don't have the data and we don't have the information of whether or not a t-shirt was classified as satisfying all quality checks or not. In this case, what we're lacking in terms of statistic speech is we don't have a target variable, because we don't have the information in our data set which tells us yes, okay, or not okay. In this case, we cannot employ what is called supervised learning because we cannot predict something that is simply not present. Because remember, we need a historic data set for the machine to learn. This does mean that we cannot do anything, however. If you have a data set where you would want the machine to learn a certain task, but you don't have the data on the target variable, you can still do something like clustering, right? So even if you don't have the information whether or not a t-shirt was produced as okay or not okay, you could still write an algorithm which clusters all of your t-shirts in, let's say, blue t-shirts or XL t-shirts or something, a certain type of t-shirt. So when we talk about unsupervised learning, there's many things that you can do with that, but typically what the most important use case in that is what is called clustering methods. So this is really used when we want to, for instance, do customer segmentation. If you have your data set of customers, then you can do unsupervised learning to create different clusters of your customers and classify them in, for instance, female, very well educated, willing to buy a lot versus male, uneducated, not willing to buy a lot. Good. In the third category of machine learning is what is called reinforcement learning. And this is the one that you'll be in touch with least, because this is still something that's being done in academia. So it's still in its infancy. But the idea is that the way a machine learns there is that you don't have to feed it data. So the big advantage of that is you don't need historic data sets. You don't need customer data or anything, but essentially you simulate data. So you put a certain machine learning model in an environment where it acts in a certain way and gets points based on the way it acts. So you can think of something like a flight simulator, where the machine learning model is simulating a certain flight, and for every flight it gets a certain score, and it basically creates its data like this by itself by running 1 million simulations, and in each of the simulations it behaves in a different way, and it performs its task in a different way, and it then figures out how to perform the task optimally. Good. This is the types of machine learning machine learning there are. Let me give you an example of a very, very simple machine learning model to make this less abstract. So let's say we have a historic data set about bank customers. So we're in the loan applicant sector again, in the loan applicant use case. And let's say we have a data set which contains some customer ID, the name of a person, the age, the gender, the income, the employment status, along with the information of whether or not they paid back a loan. Because recall, this is historic data. So these are loans that I've already given out. If I feed this data into a machine learning algorithm, a very simple model are so-called decision trees. And the model basically would come up with such a decision tree by means of which it arrives at a decision. And so in this image, you can see that there's a very simple decision tree. And the model has apparently identified the pattern that if someone is, for example, male, so I'm going up from gender, and if this person's employment status is freelance, then by looking at the historic data, I, as the model, say this person will not pay back. So at the end of model training, what you have is basically a model like this. And then what you can do is you can use this model to make predictions on new data points. So let's look at myself. Let's take me as an example. And let's say I apply for a bank loan at this bank who uses this model. What this model would do for me is it would say, hey, Michael, your gender is male, which is something which already I don't like. And then your employment status is also freelance, you're not going to pay. Whereas let's say if you had been female and your income had been more than $10,000 per year, then you would have been classified by this algorithm as, yes, you will pay. Okay, so this is a very, very simple this is a very simple example of a machine learning model, but basically you can think of it like this. There are many, many other model types that are much more complicated, but this is the most, I think, comprehensible one. Good. I've just mentioned it, and I just want to get into this real quick so you've heard the term and get a sense of what I mean when I talk about more complex models. The machine learning model type, which in the past 10 years has created the most impressive results and really impressive ones, are what are called neural networks. And so I've said this before, but basically their idea is that they emulate the structure of the human brain. And they try to arrive at a decision by having a data point go through a network of what are called artificial neurons. And each of these artificial neurons will perform a certain mathematical computation and then will pass on the signal to, at the end, arrive at a certain decision. And this is basically like our brain works, right? Because let's say from our eye, we get some sort of signal in there. It's going through a few billion neurons. And then at the end of the day, we have a certain result which says, if I see a person, I say hello. And the same way is basically with artificial neural networks. So you have some sort of input layer where you have some sort of input data, let's say the age and the weight of a customer. Then this is going through hidden layers, so through the neural network. And at the end of the day, you have an output, which in our case would be trustworthy, give a credit, yes or no. If such a neural network is quite simple, we call it a simple neural network. If such a network gets very deep, we call it a deep neural network, and we call it deep learning. And the neural networks that we're using today have become really, really deep and really complicated. So we're talking about a few million of neurons. And as you see in this image, each of the neurons is typically connected to each of the other neurons. So you end up with a Cartesian product, and so you end up with billions of connections between these things. And the thing about these neural networks and why they're so powerful is that the deeper such a neural network gets, the more complex it becomes in itself. And the more complex it is in itself, then the more complex problems it can also model and it can solve. And this is especially relevant when we're dealing with unstructured data. So for instance, images. We have seen a lot of breakthroughs with neural networks in recent years in the area of object recognition and images. And because dealing with pictures is very complicated. Good. So what I want to give you now is basically a few examples of machine learning use cases or AI use cases for each of the sectors present. So I'll do this real quick, just to give you an example of what is possible and what other companies are already doing. Example number one for the IT sector is customer churn prediction. The idea in this use case is that you identify customers who are likely to churn. And churning means start buying products from another competitor. This is, for instance, very relevant for telecommunications companies or for every company which has a subscription-based model, where you try to identify, hey, if someone is not using their phone anymore or is making less calls or is sending a lot of complaints, then it means they're likely to change their provider to another telecommunications provider. And if you identify these customers, you can preemptively send a few preemptive measures. For instance, you might make them special offers so they stay rather than them leaving you. Example number two in the IT sector is website personalization. And this is basically harnessing what is called A and B testing websites. And A and B testing means you have a website, but you create two versions of it. And you give out one version to, let's say, 50 people this week, and then you give out version B to 50 people next week. And then you check which of these versions has worked better in terms of, for example, converting my website visitors into sales. Once you've done that, you can figure out, okay, maybe this website works better for people from Germany if you include German heading or something like that. And like this, you can automatically personalize your websites to increase your conversion rates. And I think this might be interesting for people beyond the IT sector. Good. Next example is agribusiness example. We talked about this last time already. Detect diseases in crops. And the idea is that there's an app called Tumanini, And it has been fed with millions of pictures of bananas and banana leaves, some of which were healthy, some of which were sick or had a certain pest. And it learned from these images to classify images that it now sees into, hey, this banana has a certain pest, yes or no. So basically you have to take a picture of a banana and then the app is going to tell you there's a 90% likelihood that this banana is suffering from a certain disease. So again, unstructured data, this is a neural network because we're dealing with images. Second example in agribusiness is predict market prices. And this is also a use case that is being done a lot and that many companies do also beyond agriculture. But the idea in this case is predict market prices of certain agricultural commodities to determine when or whether you should sell your harvests, right? Because I guess I'm not a farmer, but as a farmer, you have the option to somehow store some of your crops and keep them for a bit, or you can sell them directly. And when you can predict the prices of the market, you can automatically say, hey, next week the price is going to be 10% higher, so I'll keep my stuff for now and I'll send it next week. I'll sell it next week. Example number one in the textile and apparel industry is automated quality checks. So I have myself implemented use cases like these, not for t-shirts, but for car parts or cars in total. And the idea is that you can automate the process of quality assurance and checking whether a certain product is okay or not okay. So we did this with cars or certain parts of a car, where previously there was a manufacturer who examined each product or each car part that was manufactured into yes, good or not good. And these sorts of processes today are being automated. So you have an image, you have an algorithm which looks at an image or maybe which looks at certain data. And it will be able to say, based on the image it sees, hey, there's an issue with this car part, or in this case, t-shirt. So the data that you would need to create such an image, such an algorithm is images of clothes with and without data quality issues. And then it would learn from these images, okay, if there is a white stripe or a yellow stripe, then this means it's not of high quality. Example number two. In textile and apparel is to use AI systems which have already been created for creating your color palettes. And there's many providers like this out there that you can go on right now for free. And basically what they did is they created AI systems where you can give one color and this system will give you corresponding colors that would work with this color in a certain way. So, and the way this was trained is that they basically also had a few color combinations and they probably had someone tell them, okay, this color combination works and is nice and this one is not. And so at some point they fed all of this data into a computer and the computer learned that if you combine a certain blue with a certain yellow, then this is nice. And so this system is basically able to give you a prediction of what color works with which color. Good. Sorry, there's a typo. That was the second one in textile and apparel. Tourism. Use case number one is dynamic pricing. And maybe some of you have been victim of this because a lot of people, especially flight companies are doing this. They engage in dynamic pricing. And the idea of dynamic pricing is that you, again, you change the price for which you sell a ticket based on certain variables. For instance, on the time of the day, on the day of the week, or maybe on how many people have previously looked for this ticket and certain other factors. And the idea is that you have a machine learning algorithm which automatically predicts which is the price and the lowest possible price, sorry, the highest possible price we can charge, still being low enough to beat the competition. And so it's a lot of, like, all of the companies are doing this, and this is why we use stuff like Skyscanner to find the cheapest price. But these are basically all algorithms which predict what is the best price to sell a ticket at right now. Second example that I guess might be relevant for some of you, because I had a look at a few tourism websites, is simply including a chatbot. And this chatbot could, for instance, be used on your website to help customers find the right content of your website. So let's say you're a tourism company and you have 50 tours you offer. You could have a chatbot that helps your website visitor through this menu and determine the right tour for him. So you might have a questionnaire in this chatbot which says, hey, welcome to our website. Are you interested in animals, in nature, or a nice beach? And then if I click on animals, then you say, okay, great, we have 10 tours. Which animals would you like to see, giraffes or monkeys? And like this, you basically take the load off of your own customer care and you provide a 24/7 available tool for your website visitors so that they can find their own product or the own content that they were looking for on your website. Good. So these were use cases that might be relevant, that I hope are relevant to your own sector. And these were all use cases that are already being implemented by many other companies. And I wanted to show you just one or two use cases now that are very advanced to give you an example of, to give you a sense of what is possible. So probably you will not have any of these in your company, but it might be interesting for you to simply see what's going on. And I'll limit myself to three. So the first one is PTSD detection, so post-traumatic stress disorder detection. And what a few guys in the States did, a few professors did, is they had interviews of Iraq and Afghanistan veterans, some of which had PTSD and some of which didn't. And they fed all of these interviews into an algorithm, and this algorithm is now able to classify an audio file of an interview. So if I talk like this algorithm would be able to tell me, hey, you have PTSD, yes or no. So simply based on the audio file. Example number two, which I think is one of the scariest examples, is that this were again professors from Stanford and Chicago University. What they did is they had a data set of 25,000 images of online dating profiles. And in these online dating profiles, users also indicated whether they were homosexual, bisexual, or heterosexual. They took all of this data, fed it into a machine learning algorithm, and this algorithm is now able to detect someone's sexual orientation from a facial image. Because apparently this model found that in your face, there are certain features which are indicative of your sexual orientation. And the model has an accuracy of 81% for men and 74% for women. And so, again, this is a neural network because we're dealing with image data. But yeah, I always think that this use case is crazy and somehow scary because, you know, you can think of what some governments around the world might do if they have surveillance paired with this algorithm. Good. And then the last one, which is in the area of art and painting, is we also have AI systems now which are able to draw comics for us. And the way they created this system is they had 25,000 Flintstone videos along with a certain short description of what is happening in the video. So in this case, so like this, the model learned that if I have a certain text, it means it corresponds to a certain image. And so what you can do now is you can give the model a small description of what is supposed to happen, like Fred wearing a red hat and is walking in the living room. And this model will then draw a comic or a picture like this for you. And the image you see right here is actually has been created by this model. So it's not too bad. And you wouldn't necessarily be able to say that this was created by a machine. Good. So these were a few examples just to show you what is currently possible. Remember that the process is always the same. You need a task that you want the machine learning, the machine to learn. And basically then what you have to do is you need to feed it with a lot of data, and then this machine learning model will learn by itself, in a nutshell. So this also answers the question, why machine learning and AI? Why everyone is talking about this now? Why is everyone talking about this at conferences? The reason is because now we get results that are actually good. Think of the advancements we made in machine translation. Think about object classification. Think about all of the use cases I've shown you right now. These are all advancements that were in large made possible because we had three factors. The first factor is that we have much more data available. Recall big data. So this is by far the most important one. The second one is that we have much more computational power and data storage capacities. So the use cases, especially the ones with images included in them, they require a lot of computational power. And previously, we didn't have the computational power to implement these things, but think of the webinar last week. Now we have the cloud, which is basically a network of huge supercomputers that we can rent simply whenever we need them. And these computers really have basically no limits to their power. And the third factor is that simply we have made a few advancements in terms of machine learning itself. So the algorithms have just become a bit better. And so this is also the reason why everyone is talking about this kind of stuff now. Good. So we talked about AI, which is basically simply referring to computer systems that are intelligent and are able to perform a certain task. And we've just talked about machine learning, which is the discipline which we are currently using mostly to create such AI systems. And the idea of machine learning is that we simply have to give data to a machine and it will learn from this data by itself. I would say that 90% of all of the AI systems that we create today are created with machine learning, just to give you a sense of how important machine learning is. Good. So last short section, what does all of this mean for you? Because I guess many of you will say, hey, okay, this is cool and somehow fascinating and interesting, but what does it mean for you? Advice number one I can give to you is ask yourself the question, do you really need it? So we have looked at data analytics use cases or examples that are pretty sophisticated today, right? And we have also looked at simpler ones last week. And you can think of machine learning and AI as being something like a Ferrari or a Mercedes-Benz or shooting a rocket to the moon. But you might not always have to shoot a rocket to the moon. Sometimes it's also enough to simply make fire in your house, right? So you can start small and you can try to advance the data science hierarchy of needs. So start with simple use cases, start by first even collecting data and then exploring it with simple use cases, create a few visualizations that might already help you. And once you've done all of this, at some point you can get to the top of the level and actually engage in machine learning and AI. So do you really need it? And are there maybe data use cases that are simpler and which already would bring you a lot? Advice number two. For everyone who thinks they have data which is ready to be put into a machine learning model to create a certain AI system, but you don't have the capacity or you don't have the in-house expertise or someone to do it for you, my advice is don't code because there's cloud services where you can create your own AI systems in a pretty simple way. So I haven't talked about this, but the way you would the way you would do machine learning is by coding. So by writing computer programs still. So you need to speak a certain programming language, for instance, Python. And this usually takes a lot of time. But the cloud service providers today offer also a lot of machine learning services where you can basically put in your data and analyze it and create machine learning systems in a drag and drop way. So there's no need for you to code. There's not even necessarily a need for you to understand what you're doing and how machine learning works. You can simply combine different tasks in this into a workflow, and then you can create your own machine learning system like this, simply with drag and drop. So this is a screenshot of Microsoft's Azure's service machine learning. Okay. Third advice, if you cannot build AI systems, it doesn't mean that you cannot use it, because there are many, many companies, services that offer AI-driven services and products. Okay, so this is a screenshot of Google Optimize. And Google Optimize is something like Google Analytics, which you can use for your website. And with this Google Optimize, what you can do is you can do A and B testing your website. This is what I had mentioned before. So you can try out different, let's say, pictures or different text blocks or different headings for your website and compare which of those setups or pictures works best in terms of retaining your visitors or converting. But Google Optimize also offers the service personalization. And so if you set this up on your website, what this service will do for you is it will automatically adjust the content of your website to the customer, to the website visitor, to increase conversion. And so this is obviously a highly sophisticated AI system, right? Because it makes a prediction on what setup works for which customer, and then it displays this. And there's absolutely no need for you to code or do anything at all, really. All you need to do is to define the 2 different versions you would like to test, and Google Optimize will take care of the rest for you. And like this, there are many examples of ready-to-go cloud services or even just other softwares that harness AI. And there's no need for you to create AI systems on your own. You can simply use what others have created already. And my last advice is, if you think that in your industry or with your business, there is the potential to use AI and machine learning in the future, then my advice is make it a vision and make strategic data acquisitions and data decisions accordingly. So the point is, if you want to shoot a rocket to the moon, then make this your vision. And once you have that as a vision, you can say, okay, if I want to shoot a rocket to the moon, it firstly means I need to be able to make fire. Once I've made fire, I need a motor. Once I have a motor, I need oil. And with this, I can then assemble a rocket at the end of the day. But once you have this defined as a vision, you can define the steps that you need to take to get there. And just how we'll do that is basically the topic of data strategy. And we will draft a data strategy, or we'll start drafting data strategies in the next webinar and in the last webinar in 2 weeks. So do stay tuned and also join for these webinars if you think that this applies to you. So recap, what did we do today? So we talked about AI, which is just intelligent computer systems. We talked about machine learning, which is the main way we create AI systems today. And they need to be created, need a lot of data. And so practical advice for you, if you have a lot of data, you can start creating your own AI systems with machine learning. If you don't have data and you would still like to use AI or machine learning, then there's other ready-made services that you can use in your company today, right now, to help you achieve your goals. We will look into this, how to achieve this, how to draft your data strategy next week. And then we'll also look at, once you have your data strategy, how can you implement a certain use case like we've looked at today. Good. So this basically ends the 3rd part of this webinar series. This was, again, probably the part where it was most what and how things work. And next week, we're going to be looking at how you can do things for yourself. So I hope that many people will join. I will open the floor for questions now, Edison.
Hello, thank you so much for, again, another fantastic webinar. I'm going to launch the poll again. I don't think anyone is unfamiliar with it, so please fill up the poll. It's popping up on your screen right now. Make sure that it's not minimized. We have 10 minutes for questions because Michael has to leave in 10 minutes. Yeah, so I'll begin with a pretty, well, I'm going to just launch into it. Can you conveniently use machine learning to analyze quantitative research data to arrive at predictions and prescription in a supervised learning way?
Yes. So we talked about this last time. So the answer is yes. The question is then how? And in the last slide deck of last week's webinar, we talked about different tools you can use to implement data analytics use cases. In this case, you have a predictive or prescriptive use case, and there are various tools you can use. On the one hand, you can simply use programming languages. And if you decide to do that, which takes more time, but is more sophisticated, let's say, I'd recommend you go with Python language. And then you just type in Python machine learning, you'll find tons of webinars and courses come up. Or if you want to avoid all of the coding, you can resort to one of the cloud services I've shown. So Microsoft Azure Machine Learning or AWS SageMaker, where you can simply basically import your data with a drag and drop UI user interface and then take the analysis from there.
Okay, great. The next question is from Annie, which I do think, okay, well, it's quite relevant. How can a non-tech person like myself apply AI or machine learning to ease our business activities and grow our business?
Basically, the answer is join next week's webinar. So what we'll do in the next webinar is we will draft a data strategy, or I'll show you how to draft a data strategy. And data strategy in a nutshell simply means identifying problems or areas in my business where I can use data. And many of these problems, or some of these problems, might be solved by employing AI or machine learning. And basically, we'll talk about this next week and help you brainstorm how you can use AI, machine learning, but also simply data visualization or statistics in your office, in your business, to help you achieve your goals. So I'll simply defer to next week.
Okay. She has a subsequent question, but I will, which is AI or machine learning a system or an application that can be downloaded, or how exactly it is applied? I do think that you have covered some of it in this webinar or in the previous one. So I'll direct Annie to this or the recording or the previous webinars. So because we have lots of questions coming up.
Yes.
Hold on. Well, they're mostly thank yous. I see that Bless Zatsi, you raised your hand. Would you like to, I'm going to unmute you.
Hang on, Edison?
Yes, please.
I got a few questions in my private channel.
Okay, please.
One of them was from Bless Zatsi. And she asks, is Google optimized for sale or is it free? And do I need an expert to fix it in my website for me? The answer is it's for free. Like Google Analytics, it's for free. And you do not need an expert to install it on your website and to set it up on your website. It might take you a few minutes or hours, but there's many good tutorials on YouTube. So if you type in setup Google Optimize, or if you type in use Google Optimize for website personalization on YouTube, there are many very easy to understand YouTube tutorials where you can directly set this up on your website. So yeah, free and pretty easy to use. Google, again, has made a pretty cool service there. Do you want me to continue with questions, Edison? Because I have a few more private ones.
Yeah, please. Well, currently we don't have any questions in the main chat, so please address
good.
the private ones.
All right, cool. Then another one from Amina was, what's the difference between AI and robotics process automation? Okay, so AI is basically refers to every computer system that is intelligent. And sometimes if we implant this AI, think of the mind of this into a robot, then this robot is able to create this robot is able to perform certain tasks for us. And this is basically what we refer to as robotics process automation. So with robotics process automation, you have this dimension of a robot actually performing something physically for you, whereas AI can also simply refer to softwares that are somehow intelligent. I hope that answers the question. Good. Then we had the question of Annie, which was, how can a non-tech person like myself apply AI or machine learning to ease our business activities and possibly grow our business? I think I've answered this already.
Yes.
Just join next week's webinar. And yep. There's one question of Ibu
Yeah.
Oluwa. Sorry for probably butchering your name. Google Optimize is not working on Wix. Is there an alternative? Not from the top of my head. I'm not a web developer, so I cannot say confidently that there isn't an alternative, but I'm not aware of any. So you'd have to check it out and try. Yeah, maybe just try and Google to see if there's another solution.
So I have a question. We know that there are a lot of platforms that have inbuilt, AI, machine learning, algorithms and models that people can just feed in data into and then try to generate analysis, whether it's descriptive, predictive, or diagnostic, for example, as you mentioned last week. Yes. So as a business, you have stuff from Google, you have stuff from IBM, you have stuff from, I don't know, there are so many other platforms. Yes. How would you know as a business person what is best for your business? And sometimes they offer overlapping services. So how do you decide?
Between the providers, you mean?
Yes.
Okay, yeah, that's a good question. The thing is, it's difficult to compare prices because they have different pricing regimes. So I hear you on it being difficult to decide between one simply by looking at the price. To be very honest with you, the cloud providers, or the platforms as you call them, that are most sophisticated and which also have the most market share are three ones: Amazon's AWS, Microsoft's Microsoft Azure, and Google's Google Cloud Platform. Then you of course have IBM and a few other ones, but really it's between these three, and it will be in the future. And honestly, they basically offer the same thing, and they are very similar in their prices. And at the end of the day, I always decide with what is most easy for me to use, and I always go with AWS. And let me put it this way: if you use AWS, you're making nothing wrong, because they have the highest range of services. They are probably the cheapest also, and they're very user-friendly, and it's the biggest company. So yeah.
Another question I have is, so for example, well, there are two questions actually. I mean, unless there are questions coming, also please feel free to pop them up. We have about 2-3 minutes left. For example, I am a tourism company, and you did mention that they can employ chatbots.
Yes.
So, I mean, I also shared in a previous session that I also learned to develop a very simple chatbot, but I'm just thinking for everyone to develop a very robust chatbot system. As you have mentioned, you give an example like, oh, I'm interested in visiting this part of Kenya. I want to go to the safaris. Is it feasible for a tourism operator to just go through the lessons and go for online courses and develop it? Or should this person actually employ someone to develop this chatbot for her business?
Okay, that's an excellent question. Thanks for asking that, Elson. So here's the thing. The topic of chatbots is an entire topic in itself. And within chatbots, you can have the simplest one to the most sophisticated ones. And the answer is, you can set up a chatbot for your website. I would say, I'll give you a promise, within 2 hours if you want to. A very simple one. You could also take entire courses and set up the most sophisticated chatbot there is, and train a new one to be able to have the most fanciest questions answered and to have really everything covered. Now, I personally don't think that this is always necessary. And especially if you're a small company, let's say in tourism, I would say go with one of the many chatbot providers, which offer, it's basically simply a plugin for your website, and then you have a chatbot on there. And it's very easy to set up, and it doesn't necessarily have to be very complicated, right? It can be very easily set up, like I now said. Maybe it's not even a chatbot, but basically it's just a system which answers questions, and the answers have to be a certain format. So there's not even a writing involved. Think of it more as a quiz funneling that a website visitor can take, but this can already help you a lot to direct your website visitors to the right direction.
Okay, great, thank you. I would have wanted to ask another question, which I think is for T&A, but we have arrived at 12:45, which means you have to leave for a mentoring session.
Yes.
But I mean, it's been very informative. I think everyone can agree to that. And again, if you've been following this webinar series, I really encourage you to join us for the last two, because that's where we get a bit more practical. And that's where you really see, you can maybe modify your business model and start thinking about where to start, right? The goal is to actually help everyone start thinking, where can I prepare my business to maybe be more data driven? So next session is very important. If you're here, you don't want to miss the next one. And again, thank you, Michael, and thank you everyone for being with us and for being, very engaging. So I shall have to let you go, and thank you everyone for your time.
Yeah, thanks everyone for being here, and hope to see you next week.
Thank you. Have a great week, everyone.
Yep.